Why am I holding an RSC 17 so that you can't see it? Because there are parts missing out of it that we have to make. McMaster is good, but they don't have parts for an RSC 17. And the last time I looked, the 24-hour RSC 17 part store isn't open. And it's down the rabbit hole, boys and girls. Well, here we have it laid out on the bench. This isn't the first time you've ever seen a rifle laid out on the bench. There were multiple things that had to happen in order to get this thing to run. There were four basic problems we had. We didn't have ammo. We did not have ammo, and that's 8 Lebel, and boy, have we done a lot of 8 Lebel work in this place. The issue we were going with, though, is that all of the other 8 Lebel rounds we had ever generated had been for recoil-operated equipment, and we didn't really want to do that. So then the next issue we had was we did not have an end block that was going to work. And I will tell you straight up, this end block right here doesn't work. It looks pretty, but it doesn't work. And we're going to describe why it doesn't look like an 8 Lebel, a standard curved back. We'll talk about that in a minute. Okay, so the third thing we had an issue with was the firing pin was broken. We were going to wind up having to make a new firing pin, and as you can see there, our firing pin is sticking out the front end of that now, but it wasn't sticking out the front before, and we're going to have to go back in and fix that little shiny spot right there. We'll talk about that in a minute. So ammo, end block clip, firing pin, and then the big one, the 800-pound gorilla in the whole thing, was the gas system, and that little bad boy right there had to be worked on, and we'll talk about that in depth. So in order to get this gun working, we had to make ammo, we had to make a clip that would feed the ammo, we had to make a firing pin that would touch off the ammo, and then we had to get the gas system tuned to the point where this gun would run and wouldn't bend itself. Yeah. The gas system on these two weapons is within about an inch of the same length. I've got this RSC barreled action laying next to this Garand right up where the lock and lugs are. The barrels are the same length. This particular cartridge runs in the high 50s, low 60,000 PSI range. This cartridge runs in the high 30s to low 40s. So even though the gas systems are the same length and it takes about the same amount of effort to operate both gas systems, this was going to be the special case. Because what I did not want to do, because I'm running at a lower pressure, I need more gas. And we're going to talk about the gas system here briefly and how many holes there are in this thing we had to go through. We all get used to these gas-operated rifles that have been, all of the kinks have been sorted out of them. But I'm going to tell you what, back when these guys were doing their thing, they hadn't sorted the kinks out of this gun yet. And they didn't really know where they were. And they were dealing with a propellant, as we found out, that's not totally optimum for running this. So while these two may be actually comparable power-wise, they are about as far apart as day and night when it comes to what's going on inside the gun. We were given a couple of repop end blocks for this thing, and they don't fit. They're too long, they're too fat across, and they don't fit. A while back, and I mean a long time ago, Ian McCollum sent me an original RSC 17 end block, and I'm going to tell you what, these things are so scarce. That thing showed up in its own Pelican case. The FedEx guy waited while I got all these measurements off an original RSC end block. We put it back into Pelican, taped it back in the box, and mailed it back out to Ian. And I'm telling you what, I'm surprised. One of the few times I've ever seen a FedEx guy that was probably armed, but we didn't know. So because we had the original numbers off of this, we were able to take the other repop end block that was sent to us, and you can see this thing, we've had to beat on it because there wasn't enough room. As you remember off the show mags, there had to be room for the rim to run around behind this. And then the rims are kept in here by this folded part right here, that fold and that fold, so that the rims run around, and believe it or not, this thing actually moves around in about a 5-inch radius circle, and if you drop a show mag on top of this thing, it's a perfect round part, and we're back to the show thing again. So we made an end block work. Now the problem was this particular end block had never been hardened. Neither one of these had, and they were soft as chewing gum. So we heated this thing up till it was orange, and then quenched each side of it in the water. And then we took it out. We just happened to be doing Luger strawing that day. We brought the temperature up to the 580 degree blue temperature, and we're able to come up with something that looked like this. Yeah. So as we're swimming around inside the blue there, we were able to draw this back, and it looks like one of those little spring clips you get for doing paperwork. And believe it or not, this thing, it looks like crap, but it works, and we're going to stay with this. We're leaving this one alone so that when CandRsenal does theirs, they have one that looks like a complete mag that hasn't been worked on by a trained rat. One of the things I'm suspecting about some of these earlier clips was the only hardening they got was the work hardening caused by fixing them. So you can hear a non-hardened mag. You drop it on the ground, it sounds a little tinny. This was the non-hardened repop we had, and it sounds a little bit flat. This is one we hardened, and this is what it should sound like. Ah, yes. The nose is missing off of this firing pin, and I'm going to tell you, I don't know what they put in the chamber. I don't know what happened, but this is a perfect brittle fracture, so it's almost like a taffy pull, where the gun had been dry fired so many times that this thing just popped off. Now, I've been gigged for smooth is a radius call out. I have no idea, but it's got to be a smooth curve from here all the way up to the front, or else you'll develop a stress riser and it'll snap again. I have no idea how long to make this new nose. So I'm just going to leave it way, way long, stick it up inside the bolt and trim it back till I have my 35/40 thousandths of firing pin protrusion. I tend to set all these Lebel firing pins a little bit long and cream these primers. Those shows, I'm damn near stuffing an Anvil up through the primer hole, through the flash hole, because I want to ensure that they're going to go off. Because if you squib a machine gun, that's a problem. This is a semi-automatic rifle for shoulder use. We won't be that aggressive, but we will get it to go off. So the firing pin rides on this boss right here. Let me get this pencil in here. The firing pin rides on this boss right here, and it rides on this boss right here, and it's retained by a cross pin through the bolt so that it can't come and go. It almost looks inertial. The superficial resemblance of this firing pin is, say, a 1911 firing pin, same principle, where this doesn't, there's no spring to retract it. So I'm guessing that it's not long enough to cover both ends. I don't know. We'll see. The way I intend to repair this is to cut this boss off the nose of this and turn this in one piece. There's no way to make this firing pin in one piece. I think it was centerless ground, and I don't have the ability in the shop to do it. Yeah, I could weld the nose on this, but I'm not betting the farm on a weld up here. Too much going on up here. So if I cut this taper, or cut this boss off the front, and then I'm going to make this piece here with a hole drilled up inside of it like this. And we're going to set that on there like a helmet, braze that in place, and then put it in a lathe and turn it down to the right length, and we'll just kind of sneak up on it. So that's kind of what I intend to do there. To the lathe. Success. Wow, that was a lot of fun. All right, so we wind up with a helmeted firing pin, and it's really long. So we'll put this thing together and then rotate it till it comes in here. There we go, bang. So right now that firing pin's sticking out a long way, and we know that. We left that extra so we can trim back to it. So as the bolt comes forward and rotates the rest of the way into battery, the bolt's coming forward, the locking lugs have entered the interrupter, and this grabs. Only at this point right here, the last 30 thousandths of an inch, 35 thousandths of an inch of play, is the firing pin going to be long enough to stick out far enough to be able to hit a live round. So what I'll start with doing is I'm just going to face the nose of this firing pin back until it's flush with this sticking all the way out. That's the part there that pushes. I haven't run this pin all the way home because it's a pain in the neck to drive out, so I only have it in enough to capture the pin. There's a surface back here that actually grabs the firing pin and shoves it back out of the way. So we'll cut the nose of the pin off, and then I'll start milking it in until I get it where I want it. There's a little bit of testing there. We'll go out and we'll put a dummy, just a empty casing of the primer and pop it, make sure we don't poke a hole through it, put a hemispherical end on it, and then we'll move on to the gas system. No lack of parts in this gas system here. This is a threaded spud that threads on, and I don't want to take it off because this, I believe, is an original spud, and it's been on there for 100-something years, and this bad boy is torqued on tight. But there's actually a hole in this, and it's a very long hole. Typically, gas ports are actually only the thickness of the barrel, and then they pressurize what's on the other side of it. This part fits up against kind of as a disassembly piece, and there's a plenum that's formed by this ring here. You can see how this has been kind of cut back in here. So this hole blows into the inside of this cup right here, blows up in that cup, blows through these two holes right here, that hole, and there's one on the other side, which pressurizes this plenum around the outside of this, which then blows through a hole that's up on the inside of this ring. Let's see if we can get that with the way the lighting is here. There it is. You can, oops, bounce the camera. You can see there's a hole up inside there, right there at the end of that bullet tip, which then blows gas through a hole that's probably a good 3/8 of an inch long. And then from that hole, this is a gas seal and a labyrinth packing right here. This is a labyrinth packing that screws into the end of this whole thing. And after you get through all of that, do you gain access to the end of the piston. Yikes. So once we developed the ammo, we worked the ammo up until we got no pressure signs on the primer and until we had a clean chamber, and we worked up the ammo. We had some original powder B, and the original powder B was given to us from French bullet poles. And what we found was we were running out of pressure before we had enough gas to even bump this gas piston backwards a little bit. We came to the determination that the powder B actually wasn't gonna, it had a lot of pressure, but not enough gas to operate this thing. And what we didn't want to do was set this gun up to run on ammo you can't get. So that evolution, we're gonna run the powder B in the bolt guns and not worry about it. We switched over to a powder that made significantly more gas, but not exactly the velocity we were hunting. These things are supposed to be going with a 230 grain projectile in a 23 to 2350 range. We gave up about 50 feet per second of velocity, but got enough gas to run this on a load that's reproducible by the owner of the weapon, and that was the important part. So when we got all that done, we then started back in and began to go over where all of the drag is in this system. And I'm looking at this and I'm going, okay, this particular piece right here is where all the drag is. So before we started working on it, we blueprinted it. Let me kill this light here because it got a little bit, there you go, blow out. Let me kill that light. Probably this one. There we go, now we can see it. The white is blowing this out. That's why we went to the gray towels. You see a lot of math on this because I was asking my, my engineering resident here, Reed, to do the math and tell me what a 10% increase in the area of this gizmo is. This gizmo is a drawing of this part. Don't remember what the dimensions of the part were, Let your pencil do your remembering for you, okay? So we were looking at what a 10% increase in the area of this annulus was going to be here, and what a 10% increase in the size of these holes were. These numbers that are written on this were the size of this device as we found it. So if we had to go back, I can make one of these. The other stuff I'm not so certain about. When we got all the way done, I'm going to tell you that we had to open up the area of everything downstream of the orifice in this barrel around 300%, a couple of thousandths of an inch at a time, because we were sneaking up on this thing slowly but surely. We were getting the bolt to move further and further and further back. And as the bolt was moving further back with the ammo that we had determined was the right velocity, we began to slowly but surely drill these holes open. Drill them open, drill them open, drill them open. Couple of thou at a time, snuck up on it. It took us close to a full week of playing around, pushing up the ammo power, dropping the ammo power back, until we got to the point where Eureka occurred. Down inside now, we have the gas piston that's pushing backwards. And the gas piston is pushing backwards, and there is a spring on this collar that's pushing the gas piston back forward again. The spring is pushing inside of this tube here. This tube is where the op rod locks into this. So the op rod on this thing, it's going to take off because I don't quite have it, but the operating rod on this fits into that key and is pulled forward. But simultaneously while that's happening, and I'm going to let this fly here, this tube is being pushed backwards. This tube is being pushed this way while the piston's being pushed that way. It's all relative. So what they did was use both ends of this spring, because this tube fits inside of this one. And when it goes down inside here, I'm going to slide all this up in here. Hang on a minute, I got to reach in front of the camera. This whole mess goes down inside here like this, and these two apertures line up. And when they line up, that tab pushes on the bottom of, this is the shell lifter that's pushing the shells up. So now you're using both ends of it. We see this later on in the Garand, where the other end of the operating rod spring is pushing up. Let me see if I can get this back here a little bit further. The other end of the spring is pushing up on the shell lifter. It's the same principle. You're using both ends of every spring. There's really nothing new. It's all been done before. What Mr. Garand succeeded in doing was Mr. Garand had the time and the money to get this sucker right. These guys had neither the time, I'm assuming they had the limitless wealth of France available to be able to push it. But the problem is, if you'd have given Christopher Columbus the plans to an atomic submarine and all the money on the planet, he still couldn't have built it because the expertise wasn't there yet. We're into the fire control group now, and this thing is simplicity itself. Those of you that are familiar with the AR-15 or any one of a variety of other Auto 5, Garand type deals have seen this hammer arrangement before. With when you pull the trigger, that climbs out of the way. That's going to hit the firing pin, and then while your finger is actually the reset spring, the disconnector spring, that's going to come back, pop through that, and hang on to it. And then when you turn your finger loose, it pops back up ready for the next round. The ingenious part of this mess is the fact that this hammer is mounted on an eccentric. So I'm going to try to figure out how to show you this here. As I engage the safety, I want you to watch right here, and you can see that the hammer actually is coming forward. So you see how the trigger's moving? So when you engage the safety, that surface right there gets closer. So right now, that's a more open joint. And as this gets closer, you cannot disengage the trigger, and therefore it is unsafe. And yet when you roll it back here, it is on fire. Bang, and it drops. That's all there is to it. However, there is something to note. While you've got backwards pressure on this, when this thing comes in here to reset, that trigger is going to move forward, and it's going to thap your finger pretty hard. It's going to pop your finger. Mr. Garand got around that problem by spring loading the disconnector right here. So when the grand trigger comes back to reset, it comes in, hits this spring-loaded part right here, and pops behind it like that. We have the rotary bolt here like we showed before. This goes in and hits, comes into the interrupted threads in the back end of the breech, and as it goes forward. And I have this upside down. When you're looking at the gun, you're looking at it this way. And then to take it apart, you pull out on this knob and rotate this, and this whole thing is supposed to come backwards. You bring that back like that, and then this will come out like that. And that's how you disassemble it. You pull the whole bolt out to the rear. Very, very simple. As we've mentioned elsewhere, the difference in length between the bolt being not quite at battery and quite at battery is your firing pin safety interlock. Something else we got going on here. A lot of this gun was rehash of older stuff. So this is actually the forend off of a label. They had all of the machining available in order to cut the hole through it. So this entire gas system was designed to go down inside of a label forend. And it's actually, they tried to reuse as many parts as they could because they were already geared up to do it, I guess. And it's actually inspired engineering considering the amount of time that Colonel Shosho had to pull this together. And I'm telling you what, these guys were sharp. Most YouTube channels get 5 rounds out of an old-fashioned 100-year-old gun like this.
That's badass.
RSC 17. Could you imagine how long this thing would be if we actually plugged a bayonet into it? It was a real pleasure to work with you guys, and I got to tell you what, this is a unique piece of kit, and I'm kind of looking forward to doing more unique stuff like it in the future. And as always, it's been a pleasure. Yes.